scraper, and we've been using this scraper, and then finally a rasp. And I have a series of pictures to show this process that's taken place over the last month or so. So if I could see the first slide. This is the ground before we ever touched it with our scraper. Next slide, we did a simple 1 scoop wide trench. Next slide, please. Yes, and then the pile of the scrapings is behind it, or the digging is behind it, and it makes a little mound. And then we, next slide shows, I think we go to 2 scoops wide. So since we can't go any deeper, we have to go wider. There's 2 scoops wide, and to the left is a little scoop taken out. That was delivered to the mecha instrument. Let's keep going. Next slide. Look at this. At the bottom, we now see a dark patch after scraping, and that dark patch we consider to be ice. And it changes its properties over day by day. It goes kind of bluish, and then it goes whitish, and then it turns reddish. It's quite an amazing process as this ice sublimates away into the atmosphere. In other words, goes from solid to vapor without being liquid. Next slide. Shows further scraping on the soil, and the piles are getting bigger. Next slide. We extend the trench to be twice as long so that we can do the kind of activities in here we need to do to try and get samples of this icy soil. Next slide. There's a pattern. You see a 4x4 pattern of tiny little holes in the ice. This is caused by our rasp on the back of the scoop pressing against the ground and spinning out little cores of icy soil. And it's done in a beautiful way. The robotic arm team has just mastered using this tool, and they've made a 4x4 grid here, filled the scoop with about 3 cc's of icy soil. And next slide shows the latest, where we've scraped that material off the surface and actually successfully delivered it to TIGA. And to tell us about the TIGA sampling and what we're learning so far from the TIGA is the lead scientist on that instrument, Bill Boynton.
Thank you, Peter. Well, I'm very happy to announce that we've gotten an ice sample into the TIGA oven. When we first found this out yesterday, we were really pleased. There were champagne corks popping in the downlink room, and we just had a great time of it. It's something we've been waiting quite a while for. Of course, we know the GRS on Mars Odyssey discovered this ice 6 years ago, but we've now finally touched it and tasted it. That's one thing that hasn't been done before. And I'd like to say, from my standpoint, it tastes very fine. I'm very glad to be in this position. At this point, I'd like to show a little video of exactly how this process works, how we get the samples delivered to TIGA. This is an animation of the lander, shows the scoop on the robotic arm. It comes down over the TIGA instrument, pours it onto a screen. We then have a vibrator that vibrates it. Here you can see a cutaway drawing. There's you can see the doors on the top. And there's a little thing we call a whirligig that actually shakes the soil down into the oven. The oven then moves and gets connected to the mating half of the oven. We heat it up, and the gases that are generated are passed on to the evolved gas analyzer. So that's the process that we've been going through. And as I say, now we're at that point where we're starting an analysis of what turns out to be an icy soil. Now, there's not very much ice in this, and in fact, the reason for that is we had tried several times to collect an icy soil, and as Peter described, quite a few weeks, maybe even a month, were spent trying to figure out exactly how to collect an icy soil using the rasp, and we finally got to the point about 5 days ago where we were pretty sure we had perfected this technique. And everything worked fine. We got a great sample in the scoop, and we went to deliver it to TIGA, and it wouldn't pour out of the scoop. It just stuck there. And of all of the things that could have gone wrong, that was the least likely on anybody's list, that it just wouldn't fall out of the scoop. So a couple of days later, we tried again, did things a little bit quicker with the idea of maybe if it might be possibly melting due to heat generation, that we'd do it quicker and it might fall out. And still, the second time it didn't work. So we finally decided, okay, we've got to get on with analyzing just the dry soils because there's a lot of interesting science there. So we decided, while other people were working on how to deliver the ice, we would actually take a dry soil and analyze it. So we came in yesterday morning hopeful that we'd see a signal that the oven had closed and we'd collected a sample. And indeed we had that, so we're happy about that. But then when we started looking at the data, we realized that we got a little bit of ice mixed in with this sample. Now, it's not a lot, and we haven't yet completed the analysis to know exactly how much. It's probably at most a few percent, maybe even quite a bit less than that. But nevertheless, we did finally get some ice, and so I'm happy to go beyond that point. Now, the way we detected that ice was in there was by noticing the melting. When you heat up material that has ice in it, once you get to the melting point of the ice, it takes a lot more heat in order to melt the ice before you can raise the temperature. And so that's what we saw. We actually saw the melting of the ice. What we'll be doing in the next week is heating the sample up to ever greater temperatures to look for different minerals that have various reactions, giving off water, carbon dioxide, other things at higher and higher temperatures. And it's probably going to take us 3 to 4 weeks after that before we get all of the data analyzed. But one of the things I wanted to point out is that, as you probably are aware, we apply names to these features based on fairy tales. And in this particular case, since I was very certain we were going to get a sample into the oven, I decided to name this one Wicked Witch. And that was named after Hansel and Gretel, with the idea that that witch saw her final demise by being pushed into an oven. Well, in this case, if you excuse me, I have to put on the appropriate regalia for this moment. Hope my daughter's not watching, but... So it turned out that probably it would have made more sense, rather than naming this after the witch in Hansel and Gretel, to name it after the Wicked Witch of the West in The Wizard of Oz. And the reason for that is, some of you may know, when she came to her final demise, she said to Dorothy, "You cursed brat, look what you have done. I'm melting." So now I'll pass things on to Vicki, who'll talk about water in the atmosphere and other things.
Thanks, Bill. Yeah, so from ice in the soil to ice and cloud in the atmosphere. So Phoenix is giving us the first detailed information